I'm Anil Kumar sharing with you a test problem on function notation. A teacher asked his student to think of a number multiplied by 5 and subtract the product from 20. Then he asked them to multiply the resulting difference by the number they first thought of. Use function notation to express the final answer in terms of original number. Use inverse notation to express the original number in terms of the final answer. You can pause the video, answer the question, and then look into my suggestion. Now in this, let's define the number itself. So let's say let the number be n. Now it says the teacher asked his student to think of a number multiplied by 5 and subtract the product from 20. So subtract the product, that means 5 times n from 20. So what we get is 20 minus 5n. Then he asked them to multiply the resulting difference, this is the difference, by the number they first thought of. So this gets multiplied by the number they first thought of, n, right? So now the question is, use function notation to express the final answer. So this is our final answer, right? So let's call this as f of n, right? Since this is a function in independent variable n, you could think of any number and that is the result you get, which is f of n. So that is how you can express the given question or the statement as a function notation. Now you could also expand it, right? So that is actually the statement. Now let's go to the second part, then we'll get back to this. Use inverse notation to express the original number in terms of the final answer. So inverse means f inverse of n. That means we want to know n from the inverse of it, right? So that is to be done. Now whenever you have a quadratic function, the only way to get the inverse is by completing the squares and then working it out, right? So let us find inverse using completing the squares. So we can now, for part B, let me start from here. So we can write this as in terms of, let us say, let me use x and y notation now, right? So we will replace, when we are doing inverse, the independent variable by x and the dependent by y, right? So and then we'll come back to that once again, okay? So let me write this as y equals to, and expand this also, 20n minus 5n square. Okay, so since we need the number back, let me use n as such, and then we'll replace it. Okay. So now when you are trying to find the inverse of the function, then you swap x and y, right? So in this case, let us swap and write here. So we have n equals to 20y minus 5y square. Now as you can see, it's very difficult. So what we did here is, to find inverse, we swap variables, right? So that is how we got this step. Now, there are two terms with y's. So completing the squares is the only way to kind of isolate it. So we will take minus 5 common. So we are left with y squared minus 4y. Now we can do half of minus 4. So we have y squared minus 4y. Half of 4 is 2. So we'll add and subtract 2 square. So that gives us minus 5. Y square minus 4y plus 2 square is a perfect square. So we can write this as y minus 2 whole square, and minus 2 square is 4. Correct? Now we can open this bracket and then write this as, let's say n equals to minus 5 times y minus 2 whole square, and minus and minus becomes plus 20. Correct? Now we can isolate y. So let me show you this method on the right side now. So we can bring 20 on this side, so we get n minus 20 equals to minus 5 y minus 2 whole square. Dividing by minus 5, we get n minus 20 divided by minus 5 equals to y minus 2 whole square. Now we'll square root it. So whenever you square root, 2 plus and minus. So we could actually, because this is minus 5, we can multiply by minus 5, write this as 20 minus n over 5, okay, equals to y minus 2. And now we can bring 2 to the other side and isolate. So y is equals to 2 plus minus square root of 20 minus n divided by 5. Right? So in terms of inverse notation, we can write this as f inverse of n. Now basically it is not a function because we have plus and minus, right? So we strictly should not be writing f inverse of n since it is not a function, right? So we get it as 2 plus minus square root of 20 minus n over 5. So that is the inverse of the given relation. So let me write f inverse of the relation, right? So this is going to return our number back. So what you can do is you can try out with a number, take a number, let us say 2, and then see whether it works or not, right? Now there are actually two numbers which will give you will get two answers. One of them will be the right answer. Since you know inverse of a parabola, this is kind of a parabola, right? Where n is 0 and we got two zeros here. So the inverse of a parabola will be kind of like this, which will fail the vertical line test, right? So therefore this inverse is not a function. So you do get two values, right? Anyway, as per the question, that is how we need to solve it. I hope that helps. Thank you and all the best.